In this video, we'll learn how to deploy a Springboot Maven project on Docker. Docker is a platform that makes it easy to develop, ship and run containers or applications in containers. This allows you to run your application in the same environment regardless of the operating system or machine. So today I'll guide you through writing a basic Dockerfile to containerize your Springboot project, build the Docker image, run it locally, and finally push it to Docker Hub. To run this project, you need to have Docker Desktop installed on your PC. So let's get started. So here I have an already existing project, and what I'm going to do is to create a Docker file. So this is usually done at the root folder. So I'll just create a file here and name it Docker file. So it doesn't have any extensions, so it's just a Docker file. Yeah. So I'll add it to my Git profile there. So this Docker file is usually a script that Docker uses to build an image for your application, and in this script we'll define some of the steps that are necessary to package and run this Springboot project. So first stage, I'll define a stage. So I'll just put in some content here and explain it. So this is stage 1. Okay, so here we are using a base image for Maven, which includes Maven version 3.99 and an open JDK version 22. This image will provide everything we needed to build a Java application. So we label this stage as build, so that we can refer to it later in the next steps. So the reason we use a Maven image is that image will build our Springboot project, resolving dependencies, and also packaging the application into a jar. So always when you are specifying the build images, make sure that you are picking the latest one. This ensures that you don't have any vulnerabilities. So first you can go to your Docker Hub account and search for the, so for example we can search Maven here, and you'll be able to see which one is the latest stable and secure build. So for instance, we can pick this, and you can see you can download that image, but for us we want to pick so we can check on the tags, and we search for Eclipse. So these are the official images, so you can pick from the Alpine image. Okay, so the next we'll proceed with defining our Docker file. So after defining this, so I'll set a working directory. So this means any file that we copy or any commands that we run will work from that directory. So I'll specify a work directory command, and I'll specify the directory is called app. So any files we copy or commands that we run will happen in this directory. Okay, so the next file that we will copy is so we'll do a copy command, and we copy our pom.xml file. Okay, so the pom.xml file, as you know it if you've worked with Maven, so this is a key part of any Maven project or Maven project, as it will contain information about the project configuration and the dependencies. So next we'll copy also I want to copy the source folder. So what this does is we are containing all our Java source code. We are copying all our Java source code into the container. So this ensures that Docker has everything that it requires to be able to build the project. so I didn't specify one parameter here, so it means I'm copying this file here, pom.xml, to this directory that we've specified there. So same here, I'm copying all my source files into this folder. Okay, so once we've done that, we specify in the Dockerfile that it needs to run some maven command. So one of the maven commands is we'll do run command npm clean package, and then of course I can specify to skip tests. So please don't skip tests on production. This is usually important. So for this case, since our focus is to run the Docker image, so I'll skip the test for now, as this is also a basic image. Okay, so the mvn clean package command is used to build the project. The clean removes any previously compiled files. The package compiles the project and packages it as a jar. And this one, what it does is it skips the unit tests. So once we are done with this part, next we create the runtime environment. Okay, so we build the jar file. So this step is for actually building the jar file, the output file. So next we want to be able to run that, to create a runtime environment to run that jar file. So for this case, we will use a different base image for running it. So we'll use a different base image. So this one we are using an Eclipse image as well with the OpenJDK. It's built from an Alpine image, which is lighter. So it is a lightweight, it's sort of a lightweight image based on Alpine Linux. It is smaller than any standard images. So this ensures that our final container is smaller in size. So next I'll also set the working directory again. So this ensures that our commands and files we are copying are done in this directory. Next, we copy our build files. So once we build the jar file, we copy all the build files that we get from that jar file into this working directory. So remember, we are specifying in this command to copy all the files that are built from our build step. Okay, so we have files that are generated after we run this command. So we copy those files into our directory. Okay, so once we've done that, we need to specify an entry point. So I'll just put in a command here. So this is the entry point. So this is the command that will actually run when the container starts. We are telling Docker to run the Java command with -jar flag followed by the name of our jar file, which is app.jar. With this, we've defined a Docker, or we've defined how Docker should package and run our Springboot application. So next, we have to build and run the Docker container. So once we've done this, we'll go next. We'll make sure that we are in the root directory. We can see our Dockerfile. So you can see here on my terminal, I'll do this. Okay, so next I want to run my Docker image. So first is to build it. So I'll use the command docker build, and then we have to specify a tag. So I'll specify a tag and call it maybe Docker demo app. Okay, so the dot at the end, if you notice, we've put a dot at the end. So tagging is tags, it gives it a name, what our image will be called, and the dot at the end specifies the current directory as the build context, meaning Docker will use everything in this directory to build the image. So once you enter this, your image will build. So let's give it a few seconds to do that. So this will take some time depending on your machine or the speed of your internet, as it needs to download some of these images. So the build process will take some time. So you can see it's downloading the Maven dependencies. So once this is done, it will generate a final build file, the jar file. So once this is done, we can see that the building step of the image is done. So we can go to our Docker, and you can see in our Docker desktop, you can see that we have a new image which is called the Docker demo app, and we can run this. So I'll go back to my terminal and do a Docker run. So I'll just do the command Docker. So let me just clear this. So I'll clear the terminal, and that's what I've done here. So then I'll do my Docker run command. So I'll just do Docker run. I'll specify the name of my container using this command parameter name, and I'll say Docker demo app. So this will be the name of my container, and then I'll specify the port. So my application will be running on port 8080, and my container or Docker container will expose port 8080 as well. Okay, so Springboot runs on port 8080 by default, and this allows you, for you to be able to access the application, we have to expose a container port. So that's why we have this. After that, I specify the name of my image, which was the Docker demo app. Okay, and then I press enter, and you can see I have my application running here. If you come to your Docker desktop, you can see you have one running container, and you can go to it here and you can see the logs. So for us to test this application, I'll go back to my application here, and I'll add one controller. So I'll do a Java class, create a demo controller here, so that we're able to test it from our Insomnia client. So I'll specify that this is a REST controller, and then I'll define one endpoint, call it test Docker. So this is the path, and I want it to just return a string. I'll say public string test Docker. So it's a get endpoint that only returns a string that says hello world from Docker. So these are simple API. So I'll stop this, and you can have it running. We can rebuild the image and run it. So while it's building, I'll come back to this, and I'll delete this container here. Then we can have it running again. So I'll redo the run. So this will be my run. Then yeah, so we are running the application after our build. So it is started. So let's go to our client here. I'll create a new request. So this is a GET request. I'll do HTTP localhost 8080, and then I'll do tests. Let's see. Yeah, test Docker and resend. So you can see we get a response from our container, and you can, so once you send a request, you can actually see, go to your container, running container, and you can see your demo app is running from here. So one more thing, so you'll notice that we have not specified, we've not configured our project to handle dynamic journeys. So one of the things you can do is on your project build file, that is on POM file, you can update it so that we have a dynamic name. So I can add a tag here called final name, and you can put some parameters here so that it picks the name and the version automatically, so that it picks the name from here and the version automatically, so that when you're building you don't have to be changing the name. So this configuration automatically names the jar file as artifact id version.jar. So whenever you build the project, this is useful for tracking different versions of your app, and our Dockerfile will be able to automatically pick up the correct jar file. So this is it. In the next video, I'll show you how to have this image pushed to Docker Hub and be able to run it in your local Kubernetes instance.